Yes? No?
Nothing.
Maybe? All right.
We were just smiling at you.
No, we were smiling, Mr. Davis.
Because we just love this class so much.
We do. We love the
We just love
parameter.
being able to figure it out on our own.
All
Seems like
right.
losing Nathan.
So let's go back over some very basic things that we have been doing for almost this entire semester.
I think that's a good
That was
idea.
fun.
So,
Oh wait, it's not.
what is the formula for confidence interval?
Statistics plus or minus.
So, it's the statistic.
Mhm.
So, what is that? What is a statistic?
That would be the.
That would
You
be
want to give me the equation?
Well, what is a statistic?
like a sample.
It's a number that you have derived from the sample.
Okay.
So, the mean of the sample, if you're doing means, or the proportion of the sample,
Correct.
right? Or in this case, the slope of the sample, right? Anything you do from a sample and you get a mean or a proportion or the slope, that's the statistic, all right? Then plus or minus what?
The critical value.
So the critical value times what?
Standard error.
Times the standard error of
Statistic. Well,
of the statistic, right? So we're looking for the slope. So which of these two?
Rotation.
We're looking at rotation. The constant is the,
X or Y intercept.
it's the intercept.
Intercept.
It's the vertical intercept if you want to be more specific. So the statistic is right there. It's the coefficient,
Yes.
0.04625. So we can immediately eliminate B is wrong, E is wrong, right? Plus or minus, we'll deal with the critical value in just a second. And the standard error of the coefficient, that is the standard error of our statistic here, is 0.01565.
Yes.
So we can eliminate that one also. That one they mixed in the one for the mean, right, where it's over the square root of n. Okay, so we've got that part. Now, what kind of a test are we going to be doing here?
Students T.
Yeah, this is a student's T test. So, yes,
And how would we know that?
because I told you so.
Yes, sir. But if I were to be on a test, like
If it's a slope, it's a student's T with 2 less than the number in your sample degrees of freedom.
okay.
So our test is a T test, but the model that everybody booted on the last test,
Yep.
Oh.
the model is this is a student's T test with 14 degrees of freedom, or a student's T model with 14 degrees of freedom,
Why can't you use a normal model?
because it doesn't work. Partly because of the size. It's only 16 of them.
It has to be over 30 to be normal, right?
If it's over 30, we could probably get away with a normal model.
So what's the difference between a T test and a T model? Or do they like
So one is a test. The model is that graph. The
Oh.
model is the graph. And we use that graph to help us decide how likely or unlikely it is for something to happen.
Ah, okay, that makes sense.
So we're calculating this. Here we're just doing a critical value, but on the next one we'll talk about that. Okay?
Yeah.
All right, so we just need to figure out, well, what in the world is the critical value? Is it 2.145 or is it 2.131?
2.145.
So the question is, how do you know that?
Your calculator.
All right, we're going to use our calculator for this.
Woo.
So Are we looking at a distribution?
Yes, sir.
Yeah. And this is a
Students.
student's T model.
Mm-hmm.
I'm going to just say that over and over again. With 14 degrees of freedom.
Yes.
So model is like the same as distribution then?
Kind of.
Or, okay.
Yeah. The distribution is the actual, right? And it can be modeled by, it's close to being, normal, or it's close to being a student's T or something like that. The model is the mathematical perfect thing. The distribution is the actual, like if you look at a histogram, you're like, okay, the histogram's not perfectly normal ever.
Yes, but this would be normal for students T.
Don't say normal and students T in the same sentence like that. But the usual?
The usual, yeah.
Okay.
Is a student's T always -2 for the degrees of freedom?
No. For slope, it's -2.
Okay. And on the test, it was
-1.
because it's a mean.
Yeah. All right. So we want to find the in-between because we're doing a
It's a big crow.
That's a big crow. That's one of the ones that was chasing the hawk the other day.
Oh, man.
There were like 3 of them,
He's huge.
3 crows that were chasing a hawk off.
That's like
Oh,
you if you were a crow. I saw that.
You should shoot him.
That's like you if you were a crow.
All right. So what we want it to be in between, and we want a 95% confidence interval.
Ooh, yeah.
So it's 2.145. So this is A.
I would have gotten that right on the AP test.
You would have?
No, yeah, I would have. I chose A.
Okay. All right, let's look at this other one. This was taken right off of AP Classroom. So we've got all this information, and here they want the appropriate test statistic for this test. So we're finding T.
Yes.
So, oh, duh.
We're doing a T test, so we're finding T, that's part of the answer, equals, that's going to be 0.5, that's the statistic,
Correct.
minus, because we're checking it against 0,
So it's always what's in the hypothesis.
um,
Or no.
well, it certainly is for the slope problems. Over the standard error,
If it was a mean problem, it would be whatever the mean is. Or whatever the.
it would be whatever the null's
mean.
mean was, yeah.
Okay.
Oh, I see what you mean now about it being 0.
That's 13.51.
Can you do these problems for like an intercept? Or no?
We typically don't do things for intercepts.
Okay. So
In
it's
fact,
just
I don't think they ever do. I think it's only the slope,
slope, mean,
proportion,
proportion.
slope, mean, proportion, and then chi-square tests.
Oh yeah, duh. Those ones are awful.
I don't think they're that bad.
I think it's just hard
That's
to
you,
figure
Michelle.
out like
I think it's the
The
hypothesis.
difference.
That's our quiz this week, huh?
sometimes. Not the goodness of fit one, but the other two. It's hard sometimes.
So that's why I gave you the thing that
Yeah.
wrote out the hypotheses. So anyway, if you were to graph this,
I don't know why that's so funny.
so if you did this, let's go back to here. And so we're doing a student's T model. So on the model, this one had, did it tell us how many?
14
Oh,
degrees of freedom.
It'd be 14 degrees of freedom, okay.
You're,
wait, why?
Is 16 minus 2, but 16 is the sample.
because then it's 16. And we do -2 because we're going to slope.
Wait.
Are there 16, hang on
Oh,
a
no,
second.
that's number 1. What are we talking about?
Oh, that's the intercept. that's not,
Yeah.
Also, these are two different problems, so
Yeah, should we?
it didn't tell us how many.
they did not.
Womp womp.
I'm sorry.
So we couldn't do the test, but let's assume that this has 10 degrees of freedom. I'm just making something up, okay?
Do that on the test.
No.
Okay.
My teacher in class would make sense.
I'm going to say this has 10 degrees of freedom. All right. And if the t-value was 13.51,
This is for.
We get what?
oh, I should be doing greater than. What's the probability that it's that bad or worse?
What? No.
And this is 13.51. Yeah.
There's a fairly almost zero chance of getting that.
Yeah. And the chance of getting it is basically nil.
You get 4.74.
Times 10 to the negative 8, yes.
Yeah, but you got 0 is what you got. There's
I think some
basically,
kids write out .0000, etc. Because they're scared, or no.
not anyone who remembers that, we're statisticians, we're hippies. We don't care about super exactness.
No, we do not.
We're like, that's close enough. Okay, so that's what you're doing when you're doing one of these tests, is you're comparing it to the model and you're going, how likely is it when you find a p-value? When you find a p-value, what you're finding is, what's the probability, if we're using this model, that you're going to get a result like that or worse? Or more extreme is actually the way that the AP typically says it. You get a value that extreme or, that or more extreme than that. And it's like, basically you have no chance.
So it's always going to be like that, where x will be greater than or equal to r t value.
For this, yeah.
For students, t slow.
Yeah, but you're probably gonna, actually I don't think, no, you can do the test if you know how many. I'm just showing. So don't try to build a whole thing from that. I'm just telling you, in general, when you're doing a test, you're taking a model, making certain assumptions about the model, and then you're going, I got a result, I got a statistic of this number. If I get that statistic with this model, what's the probability that I'll get that statistic or more extreme in those conditions? And that's your p-value. Okay? So the p-value is the probability that you'll get that number or something more extreme, given that you are using your null hypothesis. If the null hypothesis is true, what's the probability that this is going to happen?
So it's not like samples of just that size. It's like, given the null is true.
For samples of that size, yes. Yes, you're right. So here we have a super high t-value, and you're like, yeah, basically the probability that that's going to happen is nothing, assuming that, now I did, 10 degrees of freedom?
Yeah.
So let's back up for just a second and remind you that if you do fewer degrees of freedom, let's say we only had 3 degrees of freedom and went through everything, it still looks pretty normal, but the fewer degrees of freedom it has, the fatter the tails are and the lower it is in the middle. Remember that?
Oh, yeah.
Yes, I do.
Okay, it's not when you just glance at it, you're like, that looks like a normal model. Right? You can't just glance at one of these and go, I know that it's normal, I know that it's a student's T. They look pretty similar.
Yeah.
Okay, does that help?